Lesson 10.5, Graphing Other Trigonometric Functions. For tangent, has a funny looking graph as you can see. The period is pi. A period is one up and one down, so in this particular case, that is one period, and it's just pi. So our period is pi over b if we have the a's and b's. The asymptotes are where a tangent is undefined. A tangent is undefined at pi over 2 and 3 pi over 2. Those are the dotted lines. Same is true in the negatives. So the key points we have where it crosses the x-axis are then halfway between that and the asymptote are these points. Notice the y values are a and negative a. For cotangent, it looks similar. It looks more like a reflection. The period is still pi, so it's found by pi over b. The asymptotes are where cotangent is undefined, which is 0, pi, and 2 pi. So that means the x-intercepts are now at pi over 2 and 3 pi over 2. And the key points, we have the x-intercept, and we have halfway between the x-intercept and the asymptote is when we hit a and negative a. So let's graph y equals tangent of x over 4. Well, this would be the same thing as just y equals tangent of 1/4 x. Therefore, b is 1/4. So our period is pi over b, because it's tangent. So that'd be pi over 1/4. Divide by a fraction by multiplying by the reciprocal, so that appears to be 4 pi. So remember, tangent looks like that. There's your 0. So it goes there, and half my period will be to the right and half will be to the left. Since it's 4 pi, I'm just going to make h space a pi. So here's one asymptote. So this is pi, 2 pi, negative pi, negative 2 pi. So my period between negative 2 pi and positive 2 pi is 4 pi, my period. A appears to be 1, so I'm going to put that there, and negative 1 there. Guess I don't need dots. And so halfway between the x-intercept and the asymptote is when my function hits the value a. So the graph is going to go something like that. And then, of course, repeat. So every period, in this case every 4 pi, there'll be another asymptote. So if that's 2, this is 3 pi, 4 pi, 5 pi, and 6 pi, which is 4 more than the 2. And they're going to repeat. Just move each of your points over. And there you go. Why don't you pause this recording and try number 7 on page 560. All right, a is 1/2. So if that's 1, we also know b is pi, therefore our period is pi over b, which in this case is pi over pi, which is 1. So maybe I'll call this 1, 2, 3, if I count by halves. All right, tangent starts at 0. Half the period will be on the right and half is on the left, so if the period is 1, my asymptote will be right there and there, so it goes between -1/2 and +1/2. Halfway over, between the x-intercept and the asymptote, we hit our a, which was 1/2. So the graph is going to look like that. And just repeat. Notice there's 2 spaces between the asymptotes, so just keep that up. 2 spaces between the asymptotes. The x-intercept is right in the middle between the asymptotes. And then halfway between, you have the a values. So our graph is going to go like that. There we are. Our last 2 trig functions are cosecant and secant. So here's cosecant, which is the reciprocal of sine. So you can see on the graph the blue dotted is sine, cosecant is above and below that. Like sine, the period is 2 pi. 1 full period is 1 above and 1 below. So that's 1 full period. The period then would be 2 pi over b. And the asymptotes are where sine equals 0. So the asymptotes are when sine has an x-intercept. So in this case, there's 0, pi, and 2 pi. So how you graph these is you graph sine and the asymptotes, and then you draw little loopies so that they touch the tops and bottoms of the sine. Secant is just the reciprocal of cosine, so it looks like cosecant, it's just shifted sideways. So everything is still the same, except for we'd first of all graph cosine, and the asymptotes would be where cosine equals 0. So to graph cosecant, you start by graphing sine. To graph secant, you start by graphing cosine, put in the asymptotes, and then draw the little loopies. All right, let's graph 2 times cosecant of x plus pi over 2. All right, so we know that a is 2, b is 1, h is negative pi over 2, and k is 0. So we know our amplitude is 2. We know our period is 2 pi. Since b is 1, it's not going to change anything. We know our midline is y equals k, so that's y equals 0. So it's not shifted up and down. But we do know we have a horizontal shift of pi over 2 to the left. All right, so since it's cosecant, we're going to start with sine. All right, So sine starts at the origin there. Let's our amplitude is 2. So let's just make that 2. So we'll count by ones. And we'll make that 2 pi. So we'll go over 4 spaces for 2 pi. All right, so our period, it goes back to 2 pi. So we have a, remember that's an up and a down, so we have an x-intercept in between. So the up and the down, so it's going like that. All right, but what did we not do? We did not do the phase shift, so the horizontal shift. So let's shift everything left pi over 2. So if I move every point left pi over 2, that'll be one little block in my graph. Just taking each point going left pi over 2. All right, so now we're all shifted. The only thing we have left to do is put in the asymptotes. There where we have where the red one is touching the x-axis. And then we're going to draw cosecant. So how cosecant works is it starts near the asymptote, goes down, hits the maximum or minimum of the sine function, and then goes back. So what's the answer? The orange graph is the answer. All right, why don't you pause this and try number 15. A is 1, B is 4, therefore a period is pi over 2. All right, so this is sine. So it's not shifted at all. So sine starts at the origin, goes up to the top, comes down to the bottom, and back up by pi over 2. So we're going to do a complete cycle between there. So that's the other intercept. So that's the maximum and the minimum. You see, well, that goes all the way down to there, back up to there. That doesn't look very nice. So maybe instead of doing that, we can redo our scale in the x. It might be nice to go all the way over here for the period. So we'll say that's pi over 2. And this is negative pi over 2. So the other intercepts there, and then we have our maximum and our minimum. That way it looks nicer. And it's going to continue up, back down, going the other way. All right, and then we put in the asymptotes. So we're going to start with sine, like we just did, and then we're going to put in the asymptotes. All the x-intercepts are an asymptote. And then we can draw our cosecant. So it starts near an asymptote, goes, hits the sine, and comes back. Starts near an asymptote, hits sine, goes back. Near an asymptote, hits the sine, goes back. Asymptote hits the sine, goes back. Asymptote, sine, goes back. Near an asymptote, sine, goes back. There you have it.